Hi, I'm Kat Navarro Lee, an awareness ambassador with the B Foundation for Brain Aneurysm Prevention, and I'll be speaking with one of the recipients of this year's Brain Aneurysm Preventative Research Grant Program, Dr. Peyton Nisson with the Barrow Neurological Institute. Hi, thank you so much for being with us, Peyton.
Hi, Kat. Thank you so much for having me here. It's a real honor.
Before we dive into your research, I'd just like to know a little bit more about you, and if you can just tell us about yourself and how you got into neurosurgery.
Sure. Well, I grew up in Irvine, California, in Orange County. I went to college at the University of Arizona, Tucson. I was there for undergraduate, and then I actually worked at the hospital as a technician in the pathology department running blood gases. I did that for a couple years, and then I applied to their public health school, actually, and I did that for a year. And then I got into medical school and while I was in medical school, it was kind of interesting how I got into neurosurgery. I actually didn't think I wanted to do neurosurgery. And I had a friend who was a few years ahead of me in his training and schooling. And he explained to me that there are some very competitive specialties, and neurosurgery is among them. And he said, to get matched into these competitive specialties, you need to start early on with shadowing them and doing research with their departments and getting to know the different professors and surgeons. And so he recommended I do that for the competitive specialties. And I had like a list of six or seven, and I figured neurosurgery would be an easy one to cross off the list. I think part of my hesitation was I had this notion that it was highly technical, which it is, but I didn't think I had what it took to maybe to be one of those guys. And it seemed very complicated, and it's a very long training process. So, but anyways, I shadowed the service there, and I actually had to email the chair to get approval. And he said, "It's fine, you can shadow us, but you have to shadow us for 2 weeks in a row," which is very unusual. But I agreed to it, and I spent 2 weeks on service. And every day I came home and I was exhausted and tired, but I also felt like immensely fulfilled. And the culture, the people that were there, and their curiosity for the different pathologies and the care for patients, I actually realized, it aligned very well with my personality and my interests and my talents. And so I decided to actually move forward with neurosurgery early on, and I continued working with the department there in the University of Arizona and doing research with them. And now, fast forward, yeah, I guess over a decade later, I'm still doing the training with neurosurgery, but now I'm here at Cedars-Sinai as the chief neurosurgery resident.
I like Cedars. I gave birth to both of my kids there.
Oh, wow. Amazing.
Your research investigates the connection, right, between reproductive organs and aneurysm formation. Can you tell us more about that? And first, also, how you got started on this project and what brought that interest in that focus?
Yeah, that's a great question. So while I was a medical student, I reached out to Dr. Michael Lawton at the University of California, San Francisco, UCSF, which is a very prestigious, pillar neurosurgery department in the country. And Dr. Lawton, he's very well known and does lots of cutting edge
Yeah.
research. And so that summer, I really tried to make the most of it. And I actually, I took out extra loans. I paid for everything myself to make it even possible. And I was living in this very like unusual living circumstances for like 550 a month. So I had this very affordable rent. And I would take the bus every morning, like halfway across the town, just to go to this research lab and work there. So I did that for a summer. And while I was there, with the advice of some of the fellows and other advanced researchers there, they recommend I do a retrospective study looking at some of the different past medical histories and surgical histories that were associated with neurological outcomes and aneurysm morphology. And so one of those included looking at the hysterectomy history. And believe it or not, hysterectomies are actually the second most common surgery done in the United States. It's very common. They're only second to cesareans. So, and
Mm.
for whatever reason, a variety of reasons, women have them done, but it's very common. And so we had a fairly good analysis being able to compare two groups that did and didn't have hysterectomies. And what we found at the time was that patients who had a history for hysterectomies had smaller aneurysms. They less often presented with rupture, and they often presented with a good neurologic exam. And, a big push for this study was trying to understand the difference between genders for aneurysm risk. And women, as you already know, are at a higher risk for a number of different characteristics with aneurysms, including
Mhm.
the incidence, the rupture rate, the presence of multiple aneurysms, and even the growth rate. All of those are more severe with the female sex. And so, looking at hysterectomy, we were able to kind of find something there. And again, retrospective studies, they're not the highest quality of evidence by any means, but this association that we saw definitely piqued our curiosity, and we wrote this up and we submitted it as an abstract to one of the national conferences, or it was presented as a poster. And kind of digging more into this topic, we needed to develop a plausible, mechanism of action and how this was happening because I think you don't have to be an expert in medicine to kind of scratch your head and think, how do you make the connection of the uterus, which is, for reproduction, have anything to do with brain aneurysms? And so the missing link is actually, we believe, a very important cytokine called VEGF. And VEGF it has numerous activities, but part of what it does is it regulates your blood vessels. And it's important to making new blood vessels and also breaking down old blood vessels. And it's very important in the health of your vascular system. And so during the menstrual cycle, women have the endometrium, which goes through this flux of being very thin to being very thick and rich in vascular supply as it prepares potentially for a fertilized egg to implant. And when this happens, it's regulated highly by VEGF. And other researchers out in the world have already looked into this, and this is kind of well established its role with the endometrium and the uterus. But when you have this surge of VEGF during the menstrual cycle, people have also shown that there's a systemic rise of VEGF. So not only is it really high in the uterus, it's also high all throughout the body. And it also may be going up into the brain, even where the blood vessels are, even though it's relatively distant in location. And so some other researchers actually looked at a group of healthy volunteers for a breast cancer study, and they found that post-menopause, women had a surge of VEGF. It was actually significantly higher than women in premenopause. And they also found that women who had a history for hysterectomies had significantly lower VEGF in their blood. And so now combining this with our retrospective data, it really started to kind of the stars started to align, if you will, and it seemed like there was a possibility on understanding, this mechanism. And so that led to I collaborated with one of Dr. Michael Lawton's, head researchers that he works very closely with. He's been working with him for decades, Dr. Tomoki Hashimoto, who is a pioneer in aneurysm research, and he actually developed this model to study aneurysms in mice. Studying aneurysms is very challenging. Um, Many people go on, years and years with aneurysms that don't rupture. They exist in this quiescent state. Some are small, some are big. So replicating it in an animal model in a finite period of time is very challenging. And so he figured out a way to test it in mice using elastase, this medication that they inject into the basal cisterns of the brain. And so, using that technique, we were trying to see, well, if we remove the uterus in mice, could we study this? And so we proposed this study, and we developed, an idea, a hypothesis that was testable, and we submitted that grant application to the NREF, the Neurosurgery Research Education Foundation. And to our surprise and glee, we were awarded with that grant, and I went over to the Barrow Neurological Institute and we tested this. And there, and going, with these studies, you might have the world's best idea, but sometimes you're not testing it appropriately. Sometimes you're not
Mhm.
asking it appropriately, or your model doesn't, answer this question the best that could be asked, and maybe this isn't correct, and so it's important with these studies, you go in there with the understanding that, odds are you're probably not going to find what you think you're looking for. But in this case, believe it or not, we actually did find some data supporting that the mice that had hysterectomies had a lower incidence of aneurysms, and it was significant. And so,
Wow.
I don't want to, I hope I'm not leading too much with my, all the work we're doing, but yeah, and so we've been testing that, and that led to a follow-up grant application with the B Aneurysm Foundation.
Thank you so much. That is all very encouraging as far as, being able to have these new tools to be able to identify and treat aneurysms in women. I've always wondered about that link, especially, having my aneurysm grow after having kids. So I'm very curious about that link. So thank you so much for doing that research. What would success look like for you in terms of this project and what the next steps would be?
Well, it's still very early on. We have lots of work we need to do. I think the next step, as we, outlined in our proposal, would be to really focus on the postmenopausal women and using a mice model to kind of recapitulate that. We do see an increase in the risk for aneurysms in older women, and usually post-menopause, you really kind of see this difference. And there's some studies showing, after the age of 50, there's a difference, a significant increase in the risk by a number of metrics, whether it's incidence, rupture, multiplicity. And so I think extending the research to that group and further testing the idea of how being in that post-menopause state might be affecting the uterus. And, we might think that the uterus, shuts down after menopause and is no longer having the menstrual cycle. But menopause is, marked by a phase of surge of FSH and LH, and these are important hormones that regulate other hormones and other organs in your body. And it's possible that even though women enter the state of not having as much estrogen and progesterone and not menstruating anymore, it's possible when they enter into this postmenopause phase that the FSH and LH is actually causing dysregulation of VEGF secretion by the uterus. And if this is the case, this all might be just downstream from the pituitary gland as women enter this postmenopausal phase. So I think success ultimately would be able to identify and establish that link. I think we're getting one step closer to doing that. A lot of this, again, a lot of this is hypothesis driven. So, it's not a lot of data to support that. But I do think it's a possibility, and it does connect a lot of the stars, so to speak, or the dots. So hopefully one day, if we could figure out if this is the case, that the uterus is secreting high amounts of VEGF, and this becomes dysregulated in the postmenopause phase of life, if there is a way to somehow target these upstream hormones that are causing that, that might potentially help lower the risk in women. Now, obviously, aneurysms are very complex, and this is only one piece of the puzzle. Genetics, of course, has a role, environmental factors, exposures, all these things, and also location on the blood vessel can have an effect. But I think this might be a significant component. And people often focus on the difference between the genders being estrogen and testosterone. And of course, those are the two like most, widely talked about, hormone differences. But there's a lot of differences between the sexes. And I think,
Hmm.
people have looked into estrogen before and actually has shown to have some protective role with aneurysm pathology. But believe it or not, they actually did some clinical studies and they looked at the Women's Health Initiative clinical trial, and they actually found that women on hormone replacement therapy had higher risk of subarachnoid hemorrhages. So clinical data hasn't supported fully estrogen being, entirely protective. And if you think about it, men have about 1/100th to like 1/10 their circulating estrogen levels as women. And so if
Hmm.
estrogen plays such an important role in maintaining vascular integrity, you would think that men, or at least up until menopause, when men would be at a higher risk. but we don't see that. So
Yeah.
I really believe there's something more to this outside of, the more commonly talked about sex hormones that warrants, us considering something like the uterus and these other hormones, playing a role.
Right. The research you're doing is very important, and we're very grateful that you're going to be working with the Bee Foundation. So, what does it mean for you to receive this grant, be working with the Bee Foundation, having this research grant in honor of Annie Mira?
It's very exciting, and I'm deeply honored. And, I believe having the opportunity to pursue my passion and the idea, this is only, I'm sure you guys have hundreds and hundreds of applicants that are all very competitive. And so to be selected is a great honor. And I'm very grateful to this family and for you guys having this, opportunity available for researchers such as myself. And, all research and ideas start somewhere. And I think it really takes things like this to give them momentum to then maybe progress to something bigger and bigger and develop the data you need to help have even a larger grant one day and more investigation into these topics. And there's no guarantee that you're going to have all the right answers or the right idea or the right study, but this is where it starts. So yeah.
Yes, this is where it starts progress. Well, thank you so much for talking to us, and we're very excited to see you at the gala and learn more about your research as time goes.
Thank you. Thank you so much, Ken. It was a pleasure meeting you today.
You too. Thank you so much. Thanks
Thanks.
for watching, everyone.